Hey guys, today we are going to move on to negative exponents, and for today, instead of doing one of my normal keynotes, I thought we would just do little old school notes and just look at some easier examples. So with negative exponents, you will see that mainly represented by this a to the negative m power. And we have a base with a negative exponent. The simplest way to explain it right now is to say that is the exact same as writing that as 1 over a to the m. I'll explain it a little more detail in class, but today I want you guys to just get used to putting it in the denominator. So when you have a negative exponent, we want to, with all of our lessons that we do moving forward, we always want our final answer to include only positive exponents. We don't want to leave our answer with any negative exponents in it. We want to simplify it. And when I say simplify it, that means change all negative exponents into positive exponents. And we do that by simply putting it in the denominator or putting it underneath the number 1. So if we look at I guess before we jump into examples, if you think back to when you had me in 6th grade, I would have done something that looked like this, where we had, I'll go over here, where we had 2 to the third, 2 to the second, 2 to the first, 2 to the 0, 2 to the negative first, 2 to the negative second. And we would say 2 to the third is 8, because 2 times 2 is 4, times 2 is 8. 2 times 2 is 4. 2 to the first is 2. Anything to the 0 power is 1. 2 to the negative first is the same as, I guess before we get there, if you think back to 6th grade when I talked about this, I love math because it follows patterns right here. And if you guys notice, every time I go down a level, every time I lower my base by 1, I'm really just dividing my answer by 2. And if I look at that, that happens every time I move down a level of my exponents. I divide by 2, divide by 2, and that's how I'm getting these answers. Is I'm dividing by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. 1 divided by, or 2 divided by 2 is 1. And 1, if I continue that pattern, 1 divided by 2 would be 1. Oh, change colors. Would be 1/2. And if I continue to divide by 2, 1/2 divided by 2 is 1/4. And this would be 1/8. And hopefully you can see, and I'll highlight them for you, that 2 to the third is 8, and it's very similar to 2 to the negative third, which is 1/8. And it kind of shows that it has that similar characteristic. It's the same number, it's just where that number is located. So both those are 4, but for a positive exponent, 4 or 4 over 1, and for a negative exponent, it is 1 over 4. And that's true for any base that you pick. It will have the same sort of pattern here. And this is just kind of our outlier here, not outlier, but kind of it does its own little thing there. Hopefully you see that pattern emerging there. And I'm going to continue dividing by 2 just so you guys can see that pattern. Divide by 2 and divide by 2. So there's the pattern I see. So once again, the main point of this is this right here. A to the negative is the same as 1 over a to the mth. So let's look at some examples like you would see on your assignment today. So say I have a problem like maybe, that's a new page. There we go. Say we have a problem like 6 to the negative first. Well, to make that exponent positive, all I have to use is to flip it on what side the denominator it is on. So right now that's the same as 6 to the negative first over 1. So I'm just going to flip this and make this 1/6. I just put it in the denominator. Maybe I have a problem that looks like, say, 3 to the negative third. In order to simplify this and write it using only positive exponents, I can say that this is the same as 1 over 3 to the third, which is the same as 1 over 27. I want that to be our final answer. 1 to the 27th, I'll circle that, and I'll circle that there too. Okay. Maybe I give you something like just a variable. says e to c to the negative 7th. I want to rewrite that to my exponent's positive, and I just put that in the denominator and make that 1 over c to the 7th, and that's my final answer right there. Let's try one more simple one like that. Maybe I give us 2 to the negative 5th. That would be the same as 1 over 2 to the 5th, because to make it positive, I just put it in my denominator. I flip what side of the fraction bar that's on. I'm going to zoom in, hopefully. There we go. 2 to the 5th, which would be the same as 1 to the 32nd, because 2 times 2 is 4, times 2 is 8, times 2 is 16, and times my last 2 would be 32. So hopefully you see you simply just put it in the denominator. Sometimes we'll have more than one term in your expression. You might have something like 7x to the negative 3rd. So those are two separate terms there, and remember we can think of this as 7 times x to the negative 3rd. I'm just going to take this negative exponent part, this right here, and that's what goes in my denominator. So this is the same as 7 over x to the 3rd. And that's my answer right there. So only the part with the negative exponent, or only the base that has a negative exponent gets flipped to the denominator. So say I have maybe 5, say x to the 2nd, y to the negative 3rd. So that's the same as 5 times x squared times y to the negative 3rd. So I look for my negative exponent, and I have one in my negative 3. So that term goes to the denominator, and everything else stays in my numerator. So it's 5x to the 2nd all over y to the 3rd. So I'm just taking whatever my negative exponent is, and I'm putting it in my denominator, and everything else stays in my numerator. So say I had like 8 a to the negative 2nd, b to the positive 4th, and c to the negative 11th. Let's make it. Move that over just a little bit. And remember, that's the same as 8 times a to the negative 2nd times b to the 4th times c to the negative 11th. So my first job is to figure out where my negative exponents lay, and they lay right here with that base and with that base. Those two things will go to my denominator, and everything else will stay in my numerator. And before I do that, I have to highlight this or it will bother me. There's the answer for that one. That's not the same color. There we go. All right. So this would be the same as 8 stays in my numerator, b to the 4th stays in my numerator. Everything else goes in my denominator. And that's my answer right there. 8b to the 4th over a squared c to the 11th. And let's try one more like that, and we'll call it quit. Oh, I've already done number 6. This is number 7. 7. Let's do a number 8. I'm moving marks everywhere. Okay. And for number 8, let's do one that looks like... We'll do one that looks like that. Let's do 13 x to the negative 2nd, y to the negative 7th. And for that, we find our negative exponents, and cancel. And we want to find their bases. So there are negative exponents with their bases. And for this one right underneath it, my only thing that's not going to move is my 13. It's going to stay in my numerator. And my other two terms are going to switch to my denominator because they are negative. So my answer is 13 over x squared, wrong purple, 13x over x squared, y to the 7th. So hopefully some of that's making sense so far. And let's do, you have one more type of problems, and those are ones that involve coefficients that have exponents on them. So number 9, let's say I give you guys 7 squared g to the third, h to the negative fifth, j to the sixth, something like that. So step 1 is I pick my negative, or find my negative exponents, and the only one I see is right there. Everything else is going to stay in the numerator, while that's going to flip down to my denominator. So my answer will be, well, first of all, what is 7 squared? I want you guys to simplify that today. 7 squared is 49. G to the third, h to the sixth, nope, not h to the sixth, j to the sixth, all over h to the fifth. So if you notice, the only thing I'm doing is really looking for those negative exponents, and if I see them, I'm flipping them to our denominator. And that is all because of that rule that says, way back here, up here, not a highlighter, right here, that says a to the negative mth is the same as 1 over a to the m. All right, last example, number 10. I might give you something that looks like, say, 3 to the negative fourth, x to the second, y to the negative fourth. So step 1, identify those terms that have a negative exponent. There's a term, and there's a term. So I could start off by rewriting this as x to the squared is going to say my numerator. Everything else is going to my denominator, so 3 to the fourth, y to the fourth. And the last thing I want you to do to simplify your answer is to rewrite that coefficient as a whole number. And that would leave you with the answer of x squared over 81, y to the fourth. And that would be your answer for that. So I made these notes as I was literally looking off your homework, so hopefully this is a good correlation and a good demonstration of what you will see on your assignment today. If you have any questions, as always, don't hesitate to reach out to me. I haven't heard a lot from you guys.